Hello and welcome back to this series of videos on how to perform retrospective image analysis for long-term demography using Google Earth imagery. In this case, we're going to focus again on how to do the automatic detection using deep learning, but this time we're going to use open source softwares to do this process. So instead of using QGIS Pro, which is a software that has a very expensive license, I'm going to show you how an alternative way to do this with different softwares. So the drawbacks of this method is that it will require a few more steps. So it's not all integrated in just one software, but it's a mix of all of them. So we have, again, this pipeline while doing deep learning. And the first software we're going to use is going to be Roboflow. It's a very useful software. It's an online portal where we can do the labeling very easily. You can also train deep learning models there, but the user has limited credits, so it's not completely open in that way. But labeling is for free, so we're going to use Roboflow for labeling. For training the model, we're going to use a part of it's going to be Roboflow because it allows data augmentation processes, but mainly we're going to use Python. And in order not to depend on the capacity of our computer, we're going to use GoogleColab, so we can borrow a bit of an online GPU. And to train the model, we can train different ones, but I would suggest to use the YOLO model, which is open source, and it's quite updated with a high frequency. Finally, in order to do the prediction in a georeferenced picture, we're going to use QGIS with a plugin that it's called Deepness. So I'm going to show you very quickly a bit of the overall view of these different tools. So this is Roboflow. This is this online platform that allows us to do deep learning, segmentation, object detection, different tasks. But mainly we're going to use that for labeling. So we will need to create an account. I'm going to get into my account and show you a little bit how it works. So within Roboflow, you can have multiple projects. For example, I'm going to open one of these that has test images that I have uploaded here. And you can upload some images, annotate them, and then access the data set. So in this case, I already selected the individuals. For example, in this image, it comes from a Google Earth imagery, and all of this are Opuntia. This is very easy to use. It's quite intuitive to draw bounding boxes around different objects. And there are some AI-based tools where you can apply this assistant to help you speed up the process. So we would do this annotation. I'm going to leave some videos on specifically how to do that in the best way. And the Roboflow automatically splits the images between train, test, and validation set. You can see here that it allows us as well to create a version and to train the model, but this will be limited to the number of credits that you have. So we might need another tool to actually train the model. So to do so, you can see here that we can download the data set. And a good thing about this is that we can download it with different formats of the images where we will have the tiles and the labels of where the objects are found. But we might not need to download the data set if we are using GoogleColab. So we're going to use the YOLO model because it's a very good model for object detection. It's quite updated. It's open source. There are new versions quite frequently. You can have a look on the web page. I believe the last version would be 12 or 11. So yeah, this is the latest version of it. So I will upload here as well this GoogleColab notebook based on Python that allows us to train an object detection model using YOLO 11 on a custom data set. And the best thing about this is that it can contact directly Roboflow in order to access the data that we have already labeled. So in this case, this is the piece of code that will be doing this. So we need to install this library, Roboflow. and you would need to add here your API key that you would have created. I will leave a video on how to do this specifically step by step, but in this video I'm just going through the overall pipeline. And you would access the name of the project, and so the name of the folder, and then the name of the project. You would just say that we're using the YOLO 11 version for downloading the data. From here, it's just following the code. It will start training a model for this. You can actually play a little bit with the hyperparameters, a thing that we couldn't do with ArcGIS Pro. You can see the different epochs, like you can modify this in order to adapt it to yourself. This take a bit long. And at the end, you would have a confusion matrix where you can analyze the number of true positives and false positives and check the accuracy of the overall model. The ending result of this, we can check a bit of the predictions, how good the Ubuntu was detected, etc., etc. The final point about this would be to download the model to be used in QGIS. So we would need to use this line in order to download our model in ONNX format. So we will save this model. So first we'll download the model and save it to our own computer. In this case, we need to save it at local. And then we're going to use it in QGIS. So in QGIS, which I have here, for example, I have opened the satellite image and would need to go to the plugin Deepness. I have already installed it, but you might have to install it for the first time. So here in plugins, Deepness, I have Deepness here, or also this icon here, which opens the plugin, and you would select an input layer that could be a small piece of image or just like the whole satellite image, and then use a part of it where you want to do the detection. Here you would select if it's a model that segments, that finds a variable, a numerical variable, in this case would be a detector. And then you would need to import the model here that we have downloaded, the ONNX file. You have different parameters that you can adjust, like the resolution and everything. Make sure that it's on the same resolution of the trained data. Here we can select different options. If we have used the YOLO 11, we need to use, I think it was this one, but everything is quite well explained in the portal. This web page that explains the plugin, which contains some videos. I remember there were some videos explaining how it works, which is very good, and you can actually see a lot of information on how it works. And I think they created a zoo with already pre-trained models. Yes, there are some videos here. Fantastic. So you can check everything, how it works and how this plugin is using pre-trained models in order to find certain objects. So I'm gonna jump into, for example, in this case, the results, the output would be the layer with the detection options and with the detected objects. And if I remember correctly, yes, here is the model zoo where you can download certain models that are already trained and that can be used for different purposes, and you can use them in QGIS. So this is the pipeline in order to do automatic detection using open source softwares. Thanks for watching and see you soon.